Okay, now basically we are going to perform that pocket operation, huh? So for that we are going to make the job first. So here I'm going to take a 2D rectangular block. Okay, so in that beginning also I told you can perform on that 2D.
Okay.
So here we will take that rectangle again, and okay, we are going to just change it by 100 by 100 again. So just type here 100 once more, and need to define that anchor. Can you see now? So just define that anchor and just click here. Okay, inside it we are going to take one another rectangle that is going to be like 40 by 40 mm. Okay, I'm going to perform that pocket operation inside it. So okay, I didn't do that okay for that previous one, no? I think so. So you can analyze the distance also in that home. You can analyze the distance. I'll check from this point to this point. Okay, so this is 40. Okay, because it has taken, I didn't came out from that operation. Okay, that's why it happened. So I'll make that another rectangle, no worries. So just click on that rectangle. I'll write here that 100 by 100, and that is going to be on that center point. Okay, so just click here and click here on this position, and just do it. Okay, now put some chamfers or fillets on this particular component. Okay, so this is a normal one, that is 5 mm. I'll take 6 mm over here, 6, or you can say 10 mm. So let's try how much it is going to be. Yeah, it is fine. It's going to work like an AutoCAD tool, not a big issue. Okay, this is my slot, so just do it. Okay, now what we need to do is directly we will put it as an isometric material, isometric component. Okay, so just you can do that isometric. Now we are going to perform that operation on 2D. Again default. Now this time what we are going to do, we are going to define the stock first. Okay, so for our component we need to define the stock. So click on that stock. It will ask you which type of component is that, and you can just click on this all the lines, or you can say control A also. Okay, you can define as control A also, otherwise it is going to take time. You can define control A, and after that end of that selection. Now see, it's asking 100 by 100 block is there. So that problem is that we need to define this edges. So height I'm going to give it like you need to remember also when you give that height, no? So height is going to be like 30 mm. Okay, or you can say whatever 30 mm I'll give. Okay, in that direction. So you can see here now we have this block, and just do it. Okay, so we have a component over here. Now what we need to define, we need to define the operation, that is pocket. Just click on that pocket operation. It's again going to ask where you want to cut the pocket. Okay, the chain it's asking, so I'm going to click on this. Okay, change the direction, flip it in that clockwise direction. Just click on that direction and just do it. Okay, the tool operations are going to come out. Okay, default whatever that retraction, feed, and top and depth is going to be decided here. So what we need to do is we need to click on that pocket, click on that tool. So obviously we will be having that filter tooled end meal. Okay, and just none, and then again select it. Okay, and just do it. Okay, even you can give the dia also. So here you will get these are flat end mills. I'll take like 6 mm. Okay, 216, and just do it. Okay, you can define that speed. So here I'm going to define the feed rate of 1200, and 4500 is going to be my spindle speed, and this is okay, plunge rate is okay. So cutting parameters are going to play important role over here. So see here, no, this is your conventional method and this is your climb. So the tool is going to travel like this, but here that entry motions, no, that is going to tell you how you are going to do that. So here in that pocket type, no, we need to keep it standard, otherwise there are other things also. That facing style is also there. If I'm going to click here, you can see it's going to be like facing style. You can go for that Iceland, it's going to be also almost similar, and these are going to be that features it's going to cover. So we are going to keep it standard. Okay, so default it's going to take that. Stock level you want to keep after that when machining. So I'll not keep anything over here. You can do it like on the floor if you want to keep, or on the wall, just like I want to leave 0.1. Okay, no worries. So just to check that, yeah, that material is going to, but it's a 2D geometry, so no issues. So here roughing is going to be there. Okay, so what type of basically cutting method you want to use? There are a lot of movements. Okay, zigzag is there. So most probably you will see that maximum we use for this pocket, no, we are going to use either that constant overlap, or you can say that high speed. Okay, default high speed is going to be there. This is said to be that best way to work out. Okay, so measure whenever we are doing any operation. Today's time, when we are doing any machining, we need to reduce the machining time. Okay, so we need to choose that operation which is going to take less traveling of the tool, and that operation is going to be done. Okay, so that basically step over percentage I have already told you, that is according to that tool dia. That corner smoothing radius is 2. Okay, that is also okay. So entry motions, okay, see, this is, if you are going to say no, there is should be that simply that tool is going to move as I told you, zigzag or above we have given, but here that ramp walk is going to be there. Okay, this is basically that circular walk. Okay, so measure, no, when we talk about these ramp movement of the tool, this is your z direction. Okay, z is going to be like this. Okay, when you are going to click on that z clearance, you can see that is the distance. And when we another one is going to be your plunge angle. Okay, plunge angle is 3, so that is that angle between the your between the z direction. So helix is going to be that good one, so you can take helix also. Helix I have already explained you before also. So z clearance and your xy clearance your plunge angles I told you, that is going to be between the sorry. Okay, so this way we are going to decide. So right now I have taken that helix one. Okay, that round that tool is going to travel at lower side. So lead in, lead out, you can change to 60. I told you percentage of the tool is going to be 60%. And if you want to take perpendicular or tangent, that is upon you. So right now we are going to take it tangent, and we are going to do it similar for exit also. Okay, this is for entry and this is for that exit. Lead in, lead out, I told you that is for that entry of the tool and how the tool is going to exit. After that we have depth of cut. You can click on this. Okay, you can give the number of cuts like 1, and step is going to be okay, and this is also okay, it's going to take less time. Then we have linking parameters. Okay, we know about it. So clearance, you can reduce it up to 35, I can say, so that traveling of tool is going to be little lesser side. The retraction is okay, it's going to come back. Stock is okay. Depth of cut, okay, depth of cut we know how much we gave that, 30 mm. Height of that component, that was 30, no? So you can keep it like minus 31. That tool, let it go at that lower side, and let's try what happens now. Just going to click this. Can you say this? So now what we need to do, just we will check on the toolpath first. Just click.